Hello friends, welcome to the video lecture series of applications of partial differential equation. In earlier lectures, we discussed applications of partial differential equations in vibration of string and one-dimensional heat flow. Now, in this lecture, we are going to discuss applications of partial differential equation in two-dimensional heat flow. Here, in two-dimensional heat flow, the heat flows along two directions, along x direction and along y direction. Normally, the problems on this topic are given in the examination when the thin metal sheet is given and thickness of the metal sheet is very negligible, it is very small. The intention behind that is the heat flows along x-axis and y-axis, and whatever the heat flows along z-axis, that is considered as negligible. Now, we are going to discuss the problems on two-dimensional heat flow. Differential equation is partial differential equation that I will be writing directly because the proof of the partial differential equation of one-dimensional heat flow is not in our syllabus. Directly differential equation I will be writing. Okay, that is what called the Laplace equation also. And equation I will be solving under the given conditions. Yes, before going to the problem, yes, once again I am going to tell you what is there in two-dimensional heat flow. So in two-dimensional heat flow, this is the metal plate, this is the metal sheet, and thickness of the sheet is negligible. And for the sake of convenience, this sheet is placed in xy plane, and one corner of the sheet is set at x equal to 0. This is other corner of the sheet, means lower corner or lower edge, you can say, lower edge is kept on x-axis. One end of the edge is kept at x equal to 0, and here in this way, this sheet is bounded by x equal to L line. Okay, L is a real number, x is equal to L line. Here y equal to 0 means x-axis is y equals 0 line, and x equals 0 line. This is y-axis, x equals 0 line. Metal sheet is bounded by this axis, and this line x equal to L. Here, the length of the sheet, it is considered to be infinite. The sheet is very long. Then the length of the sheet is considered as infinite here. Length of the sheet is infinite. When you solve problems on two-dimensional heat flow, this differential equation of two-dimensional heat flow you have to remember. Okay, this is called the Laplace equation also. Here, we are going to solve this equation. That is to find out value of U. U is what? U is a temperature at any point of the sheet. U is temperature at any point of the sheet. Temperature at any point of the sheet. And U, temperature, is a function of x, function of y, and function of t also, where t is a time. Now, very quickly, one problem we are going to discuss. The question I am going to read first. A thin sheet of metal bounded by x-axis. Thin sheet of metal is bounded by this axis, means x-axis, and the line x equal to 0 and x equal to 1. The line x equals 0, this x equal to 0 line means y-axis, and x equals 1. If this much distance is 1, x equals 1. See, the thin sheet of the metal is bounded by x-axis, x equal to 0 line, and x equal to 1 line. Stretching to the infinity in y direction means length of the sheet is, vertical length of the sheet is infinity. It is being stretched up to infinity. The sheet is being stretched up to infinity in y direction. Has its upper and lower faces perfectly insulated. Upper face, which occurs at infinity level, and the lower face, okay, these two faces are insulated perfectly. Its vertical edge. Its vertical edge means this edge is a vertical edge. This one is a vertical edge. Vertical edge. What is there? Perfect. And its vertical edges. These vertical edges. And the edge at infinity. And the edge at infinity is horizontal, which occurs at infinity level, is maintained at 0 degree centigrade. Means along this, okay, the temperature is 0, and along this the temperature is 0. Is it? And while over the base temperature of 100 degrees centigrade. Okay, this edges at infinity and vertical edges. This vertical edge, and this base edge is maintained at 100 degrees centigrade. Base edge is maintained at 100 degrees centigrade. Find steady state temperature. You have to find out temperature at any point. You have to find out temperature at any point. So what to do here? The differential equation of one-dimensional heat flow we have to write. Here partial differential equation of two-dimensional heat flow. I am going to write that is del 2u by del x square plus del 2u by del y square equals 0. Okay, this is a partial differential equation. And the most general solution I will be writing directly, because the solution is not expected in vibration of steam problems also, and in one-dimensional heat flow the solution is not expected. This solution, u is a function of x, y and t. I am writing here y is equal to u of x, y, temperature at any point. This equals C1 cos mx plus C2 sin mx C3 e to the power m into y plus C4 e to the power m into y. This is our equation 1. This is the most general solution of this differential equation. Okay, this is what? It is the most general solution, and you can write this equation directly in the examination. The most general solution is this one. The solution, this solution, how it has come, it is not expected in the examination. This is the most general solution. Now, here we have to find out value of C1, C2, C3, C4. But we have to find out the value of C1, C2, C3, C4 under the given conditions. Yes, what are the conditions given to you? Yes, some conditions are initial conditions, some conditions are boundary conditions. In short, I am writing conditions. Here, this temperature along vertical line or vertical edge, the temperature is 0. Means along x equal to 0, u of xy, x equal to 0, y, this is y, the temperature is 0. Okay, and u of at x equal to 1, the temperature is 0. Okay, these two conditions, and these two conditions are normally common. Now third one is when y is infinity. When y is infinity, again it is equal to 0. Okay, it is given here. Here its vertical edges and the edge at infinity, where temperature is 0, that is given. Okay, now the fourth condition is what? U of, this is the fourth condition now, u of, here along equation of this is y equal to 0, u of x0, means along x direction, what is the temperature? Temperature is maintained 100 degrees centigrade. Okay, these four conditions are given. Yes, normally these three conditions are common as far as the syllabus is concerned. Engineering Mathematics 3 SPPU syllabus is concerned, these three conditions are common, and you will find out the changes in these last conditions only. Means it is very clear that whatever the solution I will be finding, further solution I will be finding, on applying these three conditions, so that particular solution will be common for almost all the problems. Okay. Now this is the most general solution. The one by one condition I am going to apply. What I am going to do? I am going to apply now first condition, u of 0 y equals 0. Okay, what is meaning of u of 0 y equal to 0? The temperature u is 0 for x equal to 0. See, for x equal to 0 along this edge, x equal to 0, temperature is 0. This condition I am going to apply. Means substitute x equal to 0 and u of 0 y equals 0 in equation 1. The equation 1 gives now u of, I am putting x equal to 0. See, I am putting x equal to 0. So put x equal to 0. The cos of 0 is 1. Okay, here I am writing cos of 0 is 1 and sin of 0 is what? 0. Cos of 0 is 1 and sin of 0 is 0. If you put x equal to 0, cos 0 is 1, c1 will remain, and sin of 0 is 0. Okay, then c3 e to the power my plus c4 e to the power, it is minus my. No? This I have not written here minus. This should be minus my. Okay, minus my. Now, u of 0 y equal to 0, its value is 0, which is given. That is the first condition you can say. And one more thing I am going to do, c3 dash e to the power my plus c4 dash e to the power my minus my. What I have done, c1 into c3, I have written c3 dash, and c1 into c4, I have written c4 dash. Okay, all are general constants. If you multiply these two general constants, the third general constant you get. If you multiply these two, then next general constant will be getting. So for convenience I have done so. That this step is not at all required. But in order to minimize the constants, okay, that's I have done. C1 into C3 is C3 dash and C1 into C4 is C4 dash. For convenience only I have done, but this step is not required at all. Now C1, here what? One second. Now C1 multiplied by C3 e to the power my plus C4 e to the power minus my. Okay. The product of these two is 0. C1, C3 to the power my plus C4 e to the power minus my. The product of these two is 0. Okay, this factor is x factor. This factor is y factor. Now, this x and y are independent here. Therefore, C1 equal to 0. Product of these two is 0, and these are the exponential terms, it's never to be negative. C1 is equal to 0. So put C1 equal to 0 in equation 1. Okay, I am putting C1 equal to 0 in equation 1. Then equation 1 becomes now u of xy. This equals C2 sin mx. C2 sin mx. C3 e to the power my plus C4 e to the power minus my. Okay, this is our equation 2 now. Substitute value of C1 equal to 0. C1 0 into this will be 0. Only this term, sine term will be there like this. Okay, this is our equation 2. Now I am going to use next condition. Next condition is what? U of 1y equals 0. U of 1y equals 0 means what? The temperature is 0 at x equal to 1 edge of the sheet, metal sheet. At x equal to 1, U is temperature is 0. Okay, that is given in the problem. Now, to substitute x equal to 1. Okay, put x equal to 1 and u of 1y is equal to 0 in equation 2, the latest equation. If you substitute here u of 1y, put x equal to 1. I am putting x equal to 1. C2 sin m into 1 means sin m means C3 e to the power my. This bracket will be as it is because we are dealing with x now. The bracket of the y will not play the role. Now, u of 1y is 0. C2 sin mx C3 e to the power my plus C2 e to the power minus my. Okay, so one more step you can do, because here one more step can be done here, or you can write here C2 product of these two is 0, therefore C2 equal to 0. Therefore sin of m into 1, sin of m is equal to 0. So sin of m equal to 0, therefore sin m is equal to sin n pi. The value of sin n pi is 0. This implies m equals n pi. The value of m v of 1. Value of m. The same thing we have done with one-dimensional heat flow problems and vibration of steam problem. Okay, m is equal to n pi. The putting value of m here again. Here one more step you can add. C2 multiplied by C3 can be written as C3 dash, and C2 multiplied by C4 can be written as C4 dash. Okay, in that way you can do. Okay, without doing so I have done. In the next problem I will do like that. Okay, it is fully dependent on us. Therefore, equation 2 implies, equation 2 is what? U of xy equals C2 into sin of m, value of m is n pi, C3 e to the power m is n pi, plus C4 e to the power minus m, like this. Okay, these are equation 3. These are equation 3. Here we found value of m and I have substituted here. The latest equation 3 I have obtained. Now, as I said earlier, you can multiply. This step is not required. Sin n pi C2 into C3, C3 dash you can write. In order to minimize the number of general constants I am doing so. This step is not at all required. What I have done? C2 into C3 is C3 dash and C2 into C4 is C4 dash. Okay. Now, this is our equation 4, you can say, or equation 3, whatever. Now, it remains to use. Now, this condition I am going to use. U of x infinity equal to 0. Okay, U of x infinity equal to 0. Now, use U of x infinity equal to 0. Yes, what is the meaning of this? The temperature at y equal to infinity, at upper edge of the sheet is 0. Now substitute y equal to infinity. Okay. But normally we do at y equal to infinity, y tending to infinity here in two-dimensional heat flow. But for safer side, okay, I will be writing y equal to infinity. Now substitute here y is infinity, sin n pi, then C3 dash e to the power n into pi into infinity plus C4 dash e to the power minus n into pi into infinity. Y equal to infinity I have substituted. And U of x infinity is 0, means temperature at upper edge is 0. Sin n pi is C3 dash and e to the power infinity. E to the power infinity is infinity, and C4 e to the power minus infinity is 0. Okay, e to the power minus infinity is 0. Sin n pi then C3 dash e to the power infinity. Just I am putting here infinity, no? And C4 into 0 will be 0. Now, here I am putting y is equal to infinity. The x and y are independent of each other. Therefore, the bracket of y component will play a role here in order to get the constant. Therefore, the sin n pi is never to be 0 because it is the x component factor. Okay. Therefore, product of these two is 0. Therefore, C3 dash is equal to 0. C3 dash is equal to 0. The why I am doing so, because C3 dash is 0. If I put C3 dash is 0, then 0 multiplied by infinity is what? 0 by 0. It will be indeterminate form. But practically, the length of the vertical length of the metal sheet is considered to be very long, very long. For safer side, we are taking pi equals infinity. But practically, it becomes very long. It is very big number, but it is a finite thing, you know. It is a finite thing practically. Therefore, finite number multiplied by this equal to 0. Therefore, C3 dash equal to 0. We are dealing with y. Sin of n pi will not play any role. The C3 dash equal to 0. So, putting value of C3 dash in equation 4. Okay, I am substituting value of C3 dash in equation 4. Now, equation 4 I am going to write. What is the equation 4? Equation 4 is, I am using the next sheet, therefore equation 4 I am going to write as it is, sin n pi, here C3 dash e to the power n pi y plus C4 dash e to the power minus n pi y. Okay, this was equation 4. Now I am substituting here, put C3 dash equal to 0. Therefore, equation 4 becomes, okay, now equation 4 becomes what? U of xy, this equals sin n pi, and C3 dash is 0. Therefore, C4 e to the power minus n pi y. Yes, C3 dash equal to 0. Now it remains to use the last condition. What is the last condition? U of means along x-axis. Along x-axis means when y is 0, along x-axis means y is 0, the temperature is maintained at 100 degrees centigrade. Okay. Now, this is our equation 5. Put y equals 0 and u of x0 is 100. Okay, here u of x0 put y equal to 0, sin of n pi as it is, e to the C4 e to the power minus n pi into 0. Is it? Now, substitute y equal to 0 here. Now, sin n pi into C4. And u of x0 is 100. It is 100. Now, this is summation right here. Okay, right. Now, 100 is equal to sin of n pi equal to this. Now, what I am going to use when this constant number is equated with the sine or cos function, we use the Fourier series, you know. We use the Fourier series. Therefore, the u of, this is the Fourier series, u of x0 or 100, this value of this is 100. This summation, this C4 can be written as Bn sin n pi. Okay, sin n pi. This is n pi. C4 dash. What is the equation 4? Let me see. Equation 4, it is n by x, you know. M is equal to n pi here. If you substitute this m equal to n pi in equation 2, sin m is equal to n pi is n by x, you know. It should be n by x. Is it? Like that. n by x, n by x and n by x. Is it? Now it is n by x, n by x. Is it? Now put y equal to 0, x is as it is. Here x is as it is, x is as it is. So this is Fourier series. Okay, this is a half range Fourier series. Half range Fourier series. Right? Now, for half range Fourier series, how did you find out the value of Bn in previous problem? Bn is 2 by, and what is the length of the this horizontal length of the sheet? Horizontal length of the sheet is 1. Okay, 1. Therefore, 2 by L is 1. This formula I am writing. See, 0 to L fx function into sine of n pi x by L. Okay, here value is what? Here L is equal to 1. Okay, horizontal length of the sheet is 1. The Bn is 2 by 1, 0 to 1. Fx is the function which is given 100, which we are going to write in terms of sine and cos, n pi x by 1. Now try to simplify it. This is 200. 100 I have taken outside. Integration of sine is what? Minus cos n pi x by n pi. Lower limit is 0, upper limit is 1. The same thing we have done in previous problems also. 200. Now minus is outside. This minus I have taken outside. N pi I am taking outside. Cos of n pi x for 0 to 1. Then minus 200 by n pi. We substitute x equal to 1 means cos n pi is minus 1 to the power n. We substitute x equal to 0 means cos 0 is 1. Okay. So this is value of Bn. And substitute value of Bn in equation 5 now. All equations I am writing. See, all solutions. In this way I am writing u of xy is 5 implies u of xy equals summation Bn sin n pi x e to the power minus n pi y. Okay, this C4 I have written replaced by summation Bn. Okay, in previous lectures we have done so, therefore I am not going to explain it much. To put value of Bn equal to 0, here putting value of Bn, if you substitute value of Bn, then u of xy, this equals summation n varies from 1 to infinity. Put value of Bn here, sin n pi x is e to the power minus n pi y, and value of Bn is what? 200 by n pi. This minus sign I am taking inside. 1 minus 1 to the power n. Minus I have taken inside, So this is the temperature at any point of the sheet. U of xy is a temperature at any point of the sheet, at any time. Metal sheet, okay? At any time. At any time t. Is it? Then in this way we have solved this problem. Now the second one. See, in second problem, as I told you, the first three conditions, first, second and third, three conditions are same. Therefore, solution up to equation number 4, correct is equation number 4, yes. Solution up to this will be, solution up to equation 5 will be same. When you apply the last condition, the further part of the solution will be little bit different. But up to equation 5, the same thing we have to repeat. Therefore, in the second problem, in order to save time, this equation I will be writing directly. This equation I will be writing directly. Now, very quickly, the second problem we are going to solve. See, this is the second one. Here, the question is very simple. Solve the equation. This is two-dimensional heat flow partial differential equation. Conditions are given. V is 0 when y is infinity. Okay, what are the conditions given to you? V is 0 when y is infinity. This is given. Then next condition, V of 0y is 0. Okay, all these things are given, no need to write. V of 1y equals 0. These are the boundary conditions given to you. X0 equals x minus x square. Okay, x minus x square multiplied by x. Now these four conditions I have to use by apply. But as I told you, the first three conditions, okay, these are same in almost all problems. This one, second condition, third condition. These three conditions are same. Therefore, I will be writing solution equation 5 directly. Okay. This by previous problem. Is on applying first three conditions. By previous problem, the equation 5 I am going to write directly. Okay, what is the equation 5? U of xy is equal to, what is equation 5? See, this is our equation 5. U of xy is sin n pi x. Sin n pi x. This multiplied by c3 dash e to the power n pi y plus c4 dash e to the power minus n pi y. Okay, this was the equation. Okay, this was the equation 4, you know. But equation 5 I have to write, you know. U of x is equation 4. And equation, we are interested in equation 5. Sin n pi x multiplied by c4 dash e to the power minus n pi y. Okay, this is our equation 5. And when we use three conditions, this is our c4 dash. You know. Equation 5 we can write directly. This equation we have obtained by applying first three conditions. Now it remains to use last condition, V of x0 equal to this thing. Okay, this I have to use, this condition I have to use. But all solutions I am writing. Why I am writing so? Because in this condition, in the previous problem, x minus x square, in place of x minus x square, 100 was there. Now here we have algebraic function. When you equate algebraic function with the trigonometric function, sine and cos function particularly, then we have to use Fourier series. That's why all solutions I am writing in this way. Sin n pi x e to the power minus n pi y, and c4 dash is replaced by summation bn in this way. Okay, in short. Now this is our equation 6. Okay. So you may write equation 6 directly also. On applying these three conditions, you can write equation 6 directly also. Now use the next condition. What is the next condition? U of, here V is given, no? Just V is given. Here it is V, because in previous problem I used U for temperature. That's why I have written here U. It is V, xy. V of x0 is x minus x square. Okay. Now substitute, put y equal to 0 in equation 6. The equation 6 gives, put y equal to 0. V of x0, put y equal to 0. Summation n varies from 1 to infinity as it is, bn as it is, sine n pi x as it is, and e to the power, put y equal to 0, e to the power 0. Okay, therefore summation n varies from 1 to infinity bn sine n pi x, e to the power 0 is 1, e to the power 0 is 1, no need to write, and b of x0 is x minus x square. Okay, now this x minus x square function we are equating with sine function. It is very clear that this is half range Fourier series. This is what? Half range Fourier series. And in half range Fourier series, we have the facility to find out value of bn directly. The formula I am writing 2 by, okay, 2 by L. L is 1 here. Okay, writing directly now. Because x lies between 0 and 1. It means the width of the horizontal width of the metal sheet is 1. 2 by L, 0 to N, L is 1. Function is x minus x square, this function always, and sine n pi x. Okay. Directly I have written. I have not written the formula, directly fx is this and L is 1. Now, what to do? Expand it using integration by part, generalized by part I am using. And many times this type of integral we have solved in previous problems. First function, integral of second function. Okay. Now next term is minus always. Derivative of x minus x square is 1 minus 2x, and integration of this complete is minus sine n pi x by n square pi square, plus derivative of 1 minus 2x is minus 2, and integration of this complete bracket is integration of sine is minus cos, minus minus will be plus cos n pi x by n pi, n square pi square is already there, therefore n cube pi 0 to 1. Okay, because derivative of minus 2 will be 0, the series will get terminated there. Now substitute x equal to 1 and x equal to 0. Now here I am writing directly. See, if I put x equal to 1, then this will be 0. Then this term will be 0 for x equal to 1. If I put x equal to 0, again this will be 0, 0 minus 0 will be 0, 0 into this will be 0. And first term is going to vanish for lower limit as well as upper limit. Now if you put x equal to 1, sine n pi is 0, here I am writing sine n pi is 0. And sine 0 is also there. So for x equal to 0, sine 0 is 0. For x equal to 1, sine n pi is 0. Means this term will be 0 for both the limits, upper limit and lower limit. What is remaining now? 2 multiplied by minus 2 is minus 4. Only single term is remaining. Pi 2 by 1. Okay, it is 2 by 1 minus 2 into 2, 4. Into n cube pi cube cos n pi x for 0 to 1 bn minus 4 by n cube pi cube. Put x equal to 1, it is cos n pi minus cos 0. Cos 0 is 1. Then minus 4 by n cube pi cube. Cos n pi is minus 1 to the power. Okay, so this minus sign you can bring inside. It is not necessary, but you can do like that. 1 minus 1 to the power n. Okay, put value of bn in equation 5, equation 6. Therefore, equation 6 implies b of xy is equal to summation bn. I will be writing value of bn here. Sine n pi x x e to the power minus n pi y, and value of Bn is what? 4 by n cube pi cube, 1 minus 1 to the power n. Okay, just at the most here, at the most you can take 4 outside, pi cube outside, because n terms you can keep inside, 1 minus 1 to the power n by n cube sine n pi x. This is n now, to the power minus n pi y. Okay, this is the temperature. What we have to find here? Solve the system of equation. Now solve this equation. So we have solved this equation. Solution of equation means what? Finding value of V at xy, and V of xy means what? Temperature at any point. Temperature at any point of the plate. Now quickly, third problem I am going to solve. In third problem also, equation 6 I will be writing directly. Write equation 5 or 6, whatever. Equation 6 I will be writing directly. Why? Because first three conditions will be common in third problem also. Only fourth condition is being valid. If you have observed that the fourth condition is being valid. Okay. Problem to problem. Now here, the question I am going to read now. A rectangular plate insulated with insulated surface is 10 centimeter wide. Okay, rectangular plate is 10 centimeter wide. Rectangular plate is 10 centimeter. This is x-axis, and y-axis. I am keeping that plate here in xy plane. One corner I am keeping at x equal to 0, and it is a 10 centimeter wide, means x equal to 10. This much distance is 10. And in this way, this is the plate, 10 centimeter wide plate. Okay, 10 centimeter wide plate. Okay, this line is x equal to 10, this line is x equal to 0. This is y-axis. And it is so long, this plate is so long compared to its width that it may be considered as infinite. It is, practically it is finite, but it may be considered as infinite, without introducing appreciable error. Okay, this fact is there. Okay, we should not introduce the errors there. If the temperature of short edge y equal to 0 is given by, see, this is the short edge, y equal to 0 is the short edge. The temperature of the short edge is given, u is equal to 20x for x 0 less than or equal to x less than or equal to 5, means for this much part of the edge of the metal sheet. What is the temperature? The temperature is 20x. Okay, temperature is for this much part, temperature is 20x, and for this much part the temperature is 20 to 10 minus 6. Okay, so we have to find out value of, okay, we have to find out, and one more thing is there, and two long edges x equal to 0, x equal to 10, as well as the other short edge are kept at 0 degree centigrade. Means this long edge kept at 0 degree centigrade, this long edge is kept at 0 degree centigrade. Okay, and the upper edge, okay, upper edge which occurs at infinity, it is occurs at the temperature is 0 degree centigrade maintained at upper edge also. Now, what are the conditions? The conditions are very clear. At x equal to u of, differential equation I am going to write. Yes, here I am writing partial differential equation del 2u. Use u here because u is used. This is the differential equation which is not given, therefore we have to write it here. Partial differential equation of two-dimensional equation. Then u of xy is 0. Here When x is 0, it is temperature is 0. See, x is 0 means this, y-axis means x is 0. Along x equal to 0, temperature is 0, U is 0. Along x equal to 10, temperature is 0 again. See, along x equal to 10, temperature is 0. In previous problem, 10 was replaced by 1. Now, here at infinity level, when y is infinity, the temperature is also kept at 0 degree centigrade. Okay, that is, three conditions are common in all these three problems. And the last condition is what? It is given to you. Last condition is given, u of, okay, here I am writing u equals 20x for this much part of the sheet. When x equal to, when, see, here I am writing in this way because u is given for this one, so I am making it more clear. Here on y equal to 0, it is 20x for half part of the, for this much part means 0 less than or equal to x less than or equal to 5, and 20, 10 minus x, 5 less than or equal to x less than or equal to 10. Okay, this is the fourth condition. Now, first three conditions previously we used. Okay, means the solution is all solutions. How do you write equation 6? I am going to write. Which one is equation 6? See? Here it is written, I think. It is equation 6. Okay, here on this sheet. Let me see. This equation 6 I am going to write. There it is. Summation bn sin n by x. See, u of xy summation bn sin n by x sin n by x e to the power minus n by y. Okay, let me check it. E to the power n by y. Is it? Now, this is our equation 6. Now, last condition I have to use. Is this, in order to use this condition, substitute y equal to 0. If you put y equal to 0, what will you get here? This is as it is, bn as it is, sin n by x, and e to the power 0 is 1. Because I am putting y equal to 0, e to the power 0 is 1. But here in this case, u means temperature at y equal to 0 along this edge is given, but this temperature is split into two different parts. On first part it is 20x, on second part it is this one. Now the Bn I am writing, formula I am writing 2 by L or 2 by 10 you can say. Fx function, whatever the function is being expanded, u of x0, sin n by x by L to dx. Okay, this is the formula. In this problem, L is 10. L is what? 10. And the function is what? Fx sin n by x by 10. Is it? Now, here in this problem particularly, you can write 1 by 5 also. So 0 to 10, the temperature is not same for 0 to 10. The temperature is different in two subparts. So what I am going to do is I am going to split integral in 0 to 5 and 5 to 10. Sin n by x and and here sin n by x. Okay, for 0 to 5, what is the temperature? For 0 to 5, temperature is 20x. Okay, for 5 to 10, temperature is what? 20 into 10 minus x dx. Okay, now these two integrals we have to evaluate. What I am going to do? 20 I am taking common because 20 into 2, 40 by 4, 10. Integral 0 to 5 x sin n by x. 20 I have taken common, 10 minus x sin n by x, like this. Okay, now the 40 by 10 is 4. Apply integration by part. Do it very carefully. First function, integral of sine minus derivative of x is 1. Integral of this is minus sine n by x by sine n by x by 10. It should be there, no? 10 is there, that I have not written. Here we have 10, here we have 10, then here n pi by 10, n pi by 10, n pi by 10 divided by n square pi square by 10 square means 100. Okay, and derivative of 1 is 0 means this is the generalized by part I used, and this is the integration of integration of first term 0 to 5. Now same integration. First function, integral of sine is minus cos n pi x by 10 by n pi by 10 minus derivative of 10 minus x is minus 1, and integration of this is minus sine n pi x by 10 by n pi by 10, n pi by 10, n square pi square by 10 square is 100. Okay, and the lower limit and upper limit pi to 10. Okay, now substitute lower limit and upper limit, that's all. Bn equal to, write it directly now. The 4 is outside. Okay, if you substitute x equal to 5, so what will you get? 5 minus 5, put x equal to 5, cos n pi by 2, cos n pi by 2. Okay, put x equal to 5, divided by n pi by 10, divided by n pi by 10, minus minus plus, put x equal to 5, sin n pi by 2, by n square pi square by 100. Okay, now substitute x equal to 0 here, but if you put x equal to 0, to due to x, if you put x equal to 0, x into 0 into this will be 0, and sine of 0 is 0, therefore this bracket will be 0 for x equal to 0, that I am not writing. Upper limit minus lower limit, okay, that I am not writing. Now in next bracket put x equal to 10. If you put x equal to 10, the 10 minus 10 is 0, this term will be 0 for x equal to 10, and sin n pi, if you put x equal to 10, sin n pi is 0, means this is 0. See, I am putting x equal to 10, I am getting 0 here, minus, put x equal to 5, 10 minus 5 is 5, 5 minus of cos, see this I'm writing in the bracket, upper limit minus lower limit, minus 5 cos n pi by minus 5, is it okay? Cos n pi by 2. Okay, put x equal to 5, minus minus 3 times, sin n pi by 2 divided by, I am putting x equal to 5 here, n square pi square by 10 square means 100. Is it? Means put upper limit, lower limit. Now bn equals. So try to simplify it now. If you look at it very carefully, because n pi by 10 I have not written here, this should be n pi by 10. Okay, this one. If you look at it very carefully, then this minus becomes plus, So this cos term after simplification, I am not going to simplify, but after simplification, it will get cancelled. So what is remaining now? 4 is outside, and sin n pi by 2, minus and minus plus sin n pi by 2 means 2 times sin n pi by 2. This divided by n square pi square by 100. Okay, this will remain. Now it is 8 into 100 is 800. I am writing sin n pi by 2. This is divided by n square pi square. Okay, in this way value of bn will be found. The putting value of bn in equation 6. Where is equation 6? This. Okay, equation 6 implies u of xy equals summation n varies from 1 to infinity. Value of bn I will be writing here sin n pi x into e to the power minus n pi y. Okay, n pi y. Now it is 800 sin n pi by 2 by n square pi square. Okay, at the most 800 and pi square you can take outside. So in this way we solve this problem. Okay, 3 problems we have solved. In all these 3 problems, 4th condition was different. So we stop here. Thank you very much.